Have you ever pondered about the arrangement of electrons in an atom? How do they know where to go or in which order to stack up? Today we're cracking open the mystery of electronic configuration. Imagine an atom as a miniature solar system. The nucleus, composed of protons and neutrons, sits at the center, akin to the sun. The electrons orbit the nucleus, much like planets circling the sun. But unlike the planets, they don't just randomly whiz around. Instead, they follow a very specific pattern, known as the electronic configuration. So, what is electronic configuration? Simply put, it's the arrangement of electrons in the various energy levels or shells around an atom's nucleus. These shells are like invisible layers, each capable of accommodating a certain number of electrons. The first shell, closest to the nucleus, can hold up to 2 electrons. The next shell can accommodate up to 8. As we move further away from the nucleus, the shells can hold more and more electrons. But how do electrons decide which shell to occupy? This is where it gets interesting. Electrons fill the shells based on energy levels, from lowest to highest. This means they'll fill the innermost shells first, before moving on to the outer shells. However, it's not as simple as filling up one shell before moving on to the next. Electrons follow a set of principles when filling the shells, known as the Aufbau principle, the Pauli exclusion principle, and Hund's rule. The Aufbau principle states that electrons occupy the lowest energy levels first. The Pauli exclusion principle adds another layer to this, stating that each orbital can hold a maximum of 2 electrons, and they must have opposite spins. Hund's rule explains that electrons fill each orbital singly before any orbital is doubly occupied. To find the electronic configuration of an atom, one needs to know the atomic number, which is the same as the number of electrons in a neutral atom. Then, following the principles mentioned before, the electrons are placed in the shells and subshells. For instance, consider an atom of oxygen, which has an atomic number of 8. The first 2 electrons will fill the first shell. The next 6 electrons will fill the second shell, giving oxygen an electronic configuration of 2 and 6. In summary, electronic configuration is the specific arrangement of electrons in an atom's shells, based on energy levels. Electrons fill up the shells from the innermost to the outermost, following the Aufbau principle, the Pauli exclusion principle, and Hund's rule. To find the electronic configuration of an atom, one needs to know the atomic number and apply these principles. So the next time you see a chemical symbol or an atomic diagram, remember the intricate dance of electrons going on at a microscopic level, invisible to the naked eye, but crucial to the very structure of the universe.